Yeah?
Finding the part of the intersect will help you with that.
With what?
Just find the price of one roll.
No, you could have just asked the cashier. Is that what you're saying?
No. How does finding those two lines intersect help you find it?
I don't know.
How do you know that?
How do I know that? Because it was a story problem. Today we're going to solve a system of linear equations in 3 variables. Kind of showed you what you're doing with the YouTube video. A linear equation in 3 variables is in this form, and A, B, and C can't be 0. If they were, then you wouldn't have 3 variables. Correct? System of 3 linear equations is a system consisting of 3 equations and 3 variables. Your solution is going to be x, y, and z. So cool. Whose coordinates make each equation in the system true. An ordered triple. We've been calling it ordered pairs all your life so far. Now we have an ordered triple.
Oh my God.
Okay? It's x, y, and z. So that's what we're doing here. So, all right, let's...
How would you write it if it was
I need a blank sheet. If it was a what?
Like if it's infinitely many solutions along a certain line. How do you write that? You know how like when they're like you write times they're all like this and they all intersect in one line instead of looking at the solutions of there can't be other equations.
All right, here's what I need you to do. Solving this system, we have to find the ordered triple that will make it true. So I'm going to write right up here, x, y, and z is what I'm looking for. X, y, and z, that's what I'm looking for. To keep yourself straight, it really, really helps. Oh, and by the way, write small. Okay? I'm going to number my equations 1, 2, and 3. And if you read this packet at all, and even if you didn't, what you do is you start with 2 equations. It doesn't matter which 2. Sometimes you look at it and say which ones would be the easiest to eliminate something. And you can start with those. And then I'll show you what you do. So you start with 2 equations. I'm going to just start with 1 and 2. And I'm going to write 1 and 2 over here. And yes, I am going to rewrite the equations. Highly recommend it. Over here. 2x, not too big. I'm not even talking right now.
I know. She's on her tongue.
Okay, I wrote down 1 and 2. Now I'm going to look at 1 and 2 and I'm going to say, what can I multiply something by to maybe say get rid of the x? Let's get rid of the x. What can I multiply by?
3.
Multiply the top by -3. Okay? And then I'm gonna get rid of x. Doesn't matter. You can get rid of x. I'm going to come over here and I'm going to rewrite equation 1. And then I'm also going to rewrite equation 2. And then I'm going to eliminate x. Because I can.
Oh, this is going to take forever.
Yes, it does. And I told you that. I warned you. I pre-warned you. 7y minus 23z equals 5. Then I'm going to label that new equation A. I'm going to label that equation A. Now, I need to go back and pick 2 more equations and eliminate x.
Do you have to do this every time?
Stop whining, just go with it. Gosh. So now I'm going to do 2 and 3. I'm going to do 2 and 3. Oh, but look, 2 and 3 are kind of pretty. Well, not really. I still have to eliminate x. It's not really. If I had done z, it would have been easy, but that's okay. I didn't. I'm going to rewrite them. So I know you all are going to try and eliminate steps. But it's okay. All right, so now I need to get rid of x because I got rid of x here. So that's my goal, is to try and get down to 2 variables. So what do I need to multiply by to get rid of x?
You don't have to do anything.
You could have, but it's not gonna help you right now.
You don't have to do anything.
So, in order to get rid of x, I gotta multiply, let's say, this by 2 and this by 3. Whatever. Go ahead, Mark. Okay. So I'm going to rewrite those equations now. 12x plus 8y minus 10z equals negative 7. And negative 12x plus, is it plus?
Negative 14.
Where? Oh, sorry. You are right. See how easy it is to screw up? And negative 12x minus 6y, this is a minus, plus 15z equals 27.
So I'm gonna get the equation.
Okay? It's easy to screw up on. You got to be really careful with your signs. Just stay with me. Hold your questions. Okay? This is a 14. This is a negative 14. This goes away. This is 8. This is a minus 6. So it becomes 2y plus 5z equals 13.
Oh, this is so gross.
This is negative 14 and 27. This is equation B. So label it B, okay? Watch. So I'm going to go over here now. And I'm going to, let's say I'm going to write A over. 7y minus 23z equals 5. And I'm going to write B over. And I'm going to look at them and I'm going to say, what do I have to multiply by to eliminate, let's say, y?
7 and 2.
3.5.
So one of them should be negative. Let's do this negative 2 and this positive 7. Told you we run out of room, don't you?
Nasty.
Okay, then I go, but you're almost done. We're almost done here. So then I'm going to go down here and I'm going to rewrite this. Negative 14y plus 46z equals negative 10. And then this becomes 14y plus 35z. 70 and 21 is 91. It's going to turn out really pretty. Yeah, it is. This goes away. And look, it's 81z equals 81. Isn't that cool? Any of the three equations, any of these, and stick y and z in and get x. It doesn't matter which one you use.
2y plus 5z.
You want to do 2? Okay, let's do 2. 6x plus, I'm just going to do it in my head. What's 4 times 4? 16 minus 5 equals negative 7. So I'm going to write here, plug y and z into 2. 6x plus 11 equals negative 7. You did something wrong. Something's wrong.
Tell me what the homework is, but how many problems do we have?
Just, I'm not going to even go there right now.
Oh,
Okay? So,
no, it's not the real.
you don't have very many of these for your homework. I promise. You have a few. I want you to practice. But flip it over.
Oh.
There's some special situations that are not this long, okay? Special situations. Can I turn this over? Okay. Up here. So, again, let's number.
I can't see.
Okay? Now we're gonna start with 1 and 2 again. We're gonna look at it and we're gonna say, I'm gonna just actually jump right in. I'm gonna say, okay, what can I multiply 1 by to maybe get rid of some variables? You want to do negative 3?
Yeah.
Okay, let's do negative 3. So down here, I'm gonna write 1 over and multiply it by negative 3. And then I'm going to write 2 below it. Ooh. something funky's gonna happen. Look it, this is gone. Bye-bye, see you later. 0 equals 2, what?
What?
What does that mean?
Wait, no, that's,
What does that mean?
oh, come on.
No solution. There's no place that these three planes all intersect together. This means no solution. Now there's some doubters in the crowd, and just to show you what I did.
Positive or negative?
8 is positive. I went and I did both of the other equations just to see what would happen. And I wanted to check just to make sure if it happens to one of them, it doesn't have to happen to all of them. If it happens to one, it's no solution. Okay? So I did it. I did it to all of them.
Wait, what happened
There
then?
could be one that would work.
I just was checking. I just wanted to see, well, if I did other two equations,
Oh,
you know, yeah, I just wanted to make sure. Somewhere along the line, you'll get something like this. Okay? Look at this down here. Yes, we got to write all that. Okay.
Wait.
Yeah, we do. All right. Let's see what happens here. 1, 2, 3. Okay? Let's start with 1 and 2 again. Let's look. Do we have to do anything to eliminate a variable here? No. We don't have to. Let's just write it over. X plus y plus z equals 6. X minus y plus z equals 6. I get 2x. The y's go away. Plus 2z equals 12. Can I simplify that?
Yeah.
Absolutely. I can divide everything by 2 and I end up with x plus z equals 2. Oh, excuse me, 6. Hello. Okay, so I'm going to label that A. X plus z equals 6. Now I'm going to do 2 and 3. Let's look at 2 and 3. Do I have to multiply through by anything to eliminate y? No. So I'm just going to write them out. Y disappears. I have 5x plus 5z equals 30. Oh, would you look at that? Look at what's going to happen. Can I simplify that?
Yeah.
What, divide by what?
5.
Oh, and look at this. This is just totally amazing. Look. They're the same equation. Isn't that nifty? So that means what?
Why don't they just go for the same equation?
Same. It's going to be one of those where all the planes intersect at a line. Infinitely many solutions, which is also consistent and dependent. Consistent and dependent.
And only 2 of the equations need to be identical.
Mm-hmm. Okay? All right.